my
as
name
well.
is Lorna Fitzsimons. I'm the program chair for this program, which is the BEng in Mechanical and Sustainability Engineering. And you will see it on the CAO as DC 194. So for those of you who may be unfamiliar with engineering, just a slide here, just to tell you really what engineering is all about. So basically, engineers take ideas and turn them into reality using science, mathematics, and imagination. As a career, engineer offers a chance to make a difference to people's lives while you enjoy a dynamic and a varied working life. Engineers are in demand worldwide because they're essential to the growth and development of every country. So you can take your skills with you. In the past few decades, I'm sure many of you will understand and can appreciate that engineers have changed the world by helping to send astronauts into space, mapping the human genome, and creating the internet. Right now, engineers are working on many innovative projects, from solar energy to synthetic organs, driverless cars to virtual reality headsets. Engineers are typically problem solvers, that's their main job, and they have a flexible, creative approach to work. Engineers can work as individuals, but mostly engineers will work as part of a broader team. An engineering qualification offers a chance to do really interesting work with very interesting people, enhance people's lives, and explore almost unlimited career opportunities. So, some of the reasons why you might consider getting an engineering degree. Well, engineering as a discipline really sets you up for professional success. And just based on some research, engineering is actually the most common degree among Fortune 500 CEOs. So even though, these people might necessarily decide to go into business at the outset, the engineering qualification gives them scope to adapt to many different environments and professions. You will have very strong problem solving and analytical skills. And as you can imagine, these are highly valued skills by employers. You can apply your engineering skills to make a positive impact on the world. And I think that's what inspires a lot of us to get into engineering, whether that's biomedical or sustainability engineering. It's recognized worldwide, so your engineering qualification can be transferred to many regions of the world as part of the Washington Accord. And last, but definitely not least, engineers are well paid. So just a little bit about my background. So why did I decide to become an engineer? Well, I think kind of looking back, I always had a strong interest in maths and physics. And again, there was some family connections as well. My grandfather came over from Glasgow and he worked as a mechanical engineer. He worked actually on in the docks in Dublin. And then he worked as an engineer for an insurance company and went around looking at the structural integrity of lighthouses, among other things. So there definitely was a bit of a family connection. So just in terms of mechanical engineering then, so many people, when they think about mechanical engineering, they think of a mechanic fixing a car in a garage. And, although definitely engineers can be involved in the design of cars, it's a much broader profession than that. So I suppose in essence, engineers apply the principles of mathematics and science to benefit humankind, and mechanical engineering is no different. You can have many variations in mechanical mechanical engineering and many different kind of possible career pathways. You can consider mechanical engineering in terms of high-end mechanical engineering design, like space shuttle, Formula One cars. You can think about biomedical engineering, the design of devices that are useful and benefit humankind, robotics, medical devices like wheelchairs, and, for example, the exoskeleton. There are other elements of mechanical engineering. Another one would be process engineering, so the design of big kind of mechanical processes to manufacture goods or materials. You can have then, when we talk about this particular program, mechanical and sustainability engineering, what we try to do is really apply the fundamentals and the principles of mechanical engineering to help develop a more sustainable world and a more sustainable economy. So everything from wind energy, the use of renewable energy like hydro, solar panels, but it's much broader than that again. So for example, as a mechanical and sustainability engineer, I'm actually involved in the design of water treatment processes. And that can be everything from desalination, so extracting the salt from seawater to benefit humankind, for example, for drinking water or for industrial process water. We're also designed in many different types of plants, whether that's petrochemical plants, food plants, pharmaceutical plants, any kind of engineering that involves kind of the design of complex processes and the control of those processes. So as I'm sure you're all aware, we know that we have enormous challenges facing humankind. So transitioning to zero carbon is one of the biggest challenges faced by humanity. And we know that our planet is in dire need of solutions for the environmental challenges we face, and many of these will be rooted in mechanical engineering. So to truly address these global challenges, if you think about it, an engineer must be able to take a holistic view, both to tackle climate change related challenges directly, but also to make wider engineering choices about the design of devices and goods, products, materials, and resources with the environment in mind. And I suppose really, if you care deeply about the environment and would like to finish university with a mechanical engineering qualification with additional skills in sustainability, this may be the perfect course for you. So just in terms of climate change and energy decarbonization, I'm sure we're all very familiar with the challenges of climate change and the links to human activities over the last 150 years since I suppose the onset of the Industrial Revolution. As engineers, then, we're very interested, obviously, in providing alternative energy sources which are not going to affect climate change or are going to mitigate the climate change challenges we face. For example, the use of solar power for solar hot water heating, or for photovoltaics for electricity, the design of wind turbines, and, as I said, other renewable energy sources. But it's not just about energy. It's also about, I suppose, mitigating pollution, again, created by mankind. So that can be aerial emissions pollution. It can be water pollution. For example, if we don't treat our wastewater effectively, we're going to have a very negative effect on the environment, leading to fish kills and eutrophication. Another important aspect is to consider the way we use materials and how we manage our waste. Obviously, we try to eliminate waste where possible, but can we recycle, can we reuse, and can we develop a more circular economy? So how can engineers help with these challenges? So this is a diagram which just shows us one of the techniques that you will learn in this course, which is called life cycle assessment. So life cycle assessment considers the full life cycle of the products and materials that we use, from, for example, the raw material through to transportation, manufacturing and processing, again, end of life transportation, use, and end of life in general. So really, I suppose from an engineering and a systems perspective, what we really want are long-term, quantitative, so we can put numbers on them, and holistic solutions. So really we want a systems approach. And this is what this course offers you. We use our engineering principles to improve the efficiency of existing systems and to better manage our existing resources. We design for sustainability at the outset. So we consider the availability of resources. We consider the lifetime that we're going to use a product or a device. We look at how we can reuse, recycle, and recover the embodied energy in these materials and devices where possible. And again, as I mentioned, we also look to develop alternative energy and material sources. So really what we're trying to do is to mitigate the environmental impact of the products and the processes that we design and use. So just as an example of how you could apply these skills to large, important global challenges. So many of you might be familiar with these. These are the SDGs, the Sustainable Development Goals. And I've just picked two here, which will kind of emphasize how this degree can be useful to you. So for example, SDG 6 focuses on clean water and sanitation and improving access to both for all. SDG 7 focuses on the availability of energy. So just in terms of SDG 7 then, so ensure access to affordable, reliable, sustainable and modern energy for all. Just some points to note, 1/3 of the world's population use dangerous and inefficient cooking systems. So how could we try and design new systems to reduce those kind of challenges and risks? 759 people lack access to electricity, and 3 out of 4 of them live in sub-Saharan Africa. And again, obviously, one of the other challenges is we want to improve the energy efficiency and improve the rates of the acceleration of these energy efficiency devices. For example, if you think about car batteries, we want to extend their use. We want to make sure increase their lifetime. And again, we want to use more renewable materials in the production of these because of, for example, it could be global issues in terms of health and safety or where we get these materials in the first place. Can we find alternative materials to reduce their overall impact? And again, as we know, we need to accelerate the use of modern renewable energy. For example, that's just not in transport, it's also in, for example, how we heat our homes. So moving from oil-fired, gas-fired central heating systems to more renewable systems like heat pumps. SDG 6 then, which sets out to ensure the availability and sustainable management of water and sanitation for all. Again, just note that billions of people worldwide still lack access to safe drinking water, sanitation, and hygiene. And in 2020, 2 billion people lacked safely managed source of drinking water. 3.6 billion people lacked safely managed sanitation, and 2.3 billion people lacked basic hygiene. So this is a typical project that I will be involved in, trying to develop more sustainable solutions for developing countries in terms of access to water and in terms of wastewater management. Again, 2 billion people don't have access to basic sanitation facilities such as toilets. And in actual fact, more people in the world currently have a mobile phone than have access to a toilet. So really what we need are low-tech, cost-effective solutions needed to protect both human health and to prevent damage to the environment. So again, this is just an example. So part of my research looks at wastewater treatment systems. They're very interesting systems from an engineering perspective. You have biological, you have physical, and you have chemical processes taking place. But if we don't manage these effectively or our wastewater treatment effectively, this is what can happen. And this is just an image I pulled from a number of years ago. My husband and I went on holidays. We were down in Killarney at the National Park. And as you can see, the lovely lakes of Killarney were not looking that lovely on this particular day because of a sewage outage to the lake. So if we can design proper wastewater treatment systems, we can prevent environmental damage, both from an aesthetic perspective, but also for the aquatic life that's actually taking place in our natural waterways. So just a little bit specific information about our mechanical and sustainability engineering degree. So there is a video here that you can link to, giving you some information about the course. Just in terms of what you will study if you do this course. So as the name suggests, it is very much a split between mechanical and sustainability engineering. So part of your education will involve learning about the fundamental principles of mechanical engineering, and that involves mathematics, mechanics, material science, modeling and data analytics, thermal fluid sciences, and design. There's also very strong focus on the sustainability aspects. So modules such as renewable energy systems, energy in buildings, process design, water and waste management, environmental legislation standards and risk, electrical power and electromechanical systems, life cycle assessment, which I mentioned earlier, and energy management. Note as well that as part of the program, you will do a paid industry work placement, which in DCU we call our intra program. So just in terms of your, I suppose, career prospects after completing a degree in mechanical and sustainability engineering, well, they're very varied. You could work in different roles in the energy, transport, manufacturing and utility sectors, for example, as a process engineer, a renewable energy engineer, an energy manager, an energy audit engineer, a project manager, an energy analyst, or a sustainable design engineer. So just a little bit of background about engineering in DCU. So in DCU, we have two schools. We have the School of Mechanical and Manufacturing Engineering, and we have the School of Electronic Engineering. Note that 90% of graduates from the Faculty of Engineering and Computing were in employment or further study 9 months after completion of their course. And this is based on a 2019 graduate outcomes survey. They're employed by the top Irish and multinational companies, including Accenture, AIG, Ericsson, ESB, IBM, Irish Life, MasterCard, PwC, Workday, Intel, and SAP. So there are a wide range of careers in a wide range of companies. DCU is ranked first in Ireland for its graduate employment rate and 23rd in the world. Okay, and that's based on QS graduate employability rankings in 2022. So why might you decide to do engineering at DCU? Well, I think it's fair to say that we have the best equipped engineering building in the country. We have a very modern campus. We have on-campus accommodation and accommodation nearby. We have a 25-meter swimming pool. We have a student hub called the U, and then we have the Helix on site. There are over 100 clubs and societies. It's a really friendly, welcoming atmosphere. So this is the building actually I'm in at the moment. As you come from Collins Avenue, when you turn into DCU, the engineering building or the Stokes building is the building you see directly in front of you. So just in terms of the two different schools that I mentioned, just a little bit of more general information about the degrees that we offer. So in the School of Electronic Engineering, there's a BEng or an MEng. So you can do a 4-year Bachelor's of Engineering or a 5-year integrated Master's in Electronic and Computer Engineering. Then there's the BEng and the MEng in Mechatronic Engineering. So Mechatronic Engineering is divided between the School of Mechanical Engineering and the School of Electronic and Computer Engineering. As the name suggests, it's a hybrid of both mechanical and electronic engineering. And then in terms of, for those of you who may not know which specific program you would prefer, there's the common entry into engineering route. So in that case, you don't specify a particular program, but after first year, you can decide which program you would prefer once you get a taster of the different engineering programs and disciplines. And there's a new BSc in Global Challenges, that's DC 189, and that is starting this September. So that's again, it's a, I suppose, a hybrid program between the School of Electronic and Computer Engineering and the School of Law and Government. So the School of Mechanical and Manufacturing Engineering, then when I work, where I work, we have the BEng and the MEng in Mechanical and Manufacturing Engineering. We have the BEng or MEng in Biomedical Engineering. And we have the BEng in Mechanical and Sustainability Engineering, which I've just spoken about. And we are currently ready to roll out the MEng, so the Integrated Masters in Program option, which will start actually this September. So that is my talk, my spiel. So if anybody has any questions, by all means, please feel free to jump in.
Thanks very much, Lorna. That was excellent. We have lots of people online actually. So if anybody would like to, maybe I can allow them to talk. If they want to speak or else put a question in the chat box, that would be perfect. Just to remind people that I'm sure you said it, maybe Lorna, it was a minimum of H4 in maths is what's required to get onto these courses, but I'm sure, oh, here we are. So from Sean, is it possible to change engineering course after 1 year?
Yes. So I mentioned that you have a choice. So basically the advice we give people is that if you know which particular program you would like to go on, we suggest that you select that in your, as part of the CAO. Now, once you have selected it, we still offer students the opportunity to change after year 1. So you have different options. You can either pick the common entry if you have no clue what you'd like to do, and then choose after year 1 which program you would like to go into. Or, for example, if you decided you wanted to pick a program and you changed your mind, you will have that opportunity at the end of year 1 as well. So it's very flexible.
Thanks, Lorna. If anybody else has another question, now is the time. You might want to say why, the way you offer the BEng, so the Masters of Engineering, what difference would that make to a student? So
again, this is one of the advantages of doing an BEng. Engineering education has changed slightly in the last number of years. So our engineering programs are accredited by Engineers Ireland. Now, engineering programs are only accredited once students have started to graduate. So when I say our programs are accredited, this one has not been accredited yet because we haven't any graduates from the program, but it's very much in line with our other engineering programs. So we don't foresee any issues with accreditation. But Engineers Ireland now stipulate that in order to be a chartered engineer, that you must have a master's qualification. Now, previously, you could get chartered status by doing a BEng and then having professional work. And I think there still is a pathway to do that. But I suppose the most straightforward pathway is to do a master's. So a lot of engineering has moved towards a 5-year model as opposed to a 4-year model. And one other advantage of doing our integrated masters is that in Intra, if you do the 4-year BEng, you will typically do a 4 to 6 month placement. If you do the MEng route, you get an extra semester on your Intra placement. So effectively, that's a 10-month placement. And I mean, that's great for anybody's CV having 10 months industry experience.
Absolutely. Dermot has asked how much practical work is there. So including the work placement is part of the course, I suppose. How much practical work is there?
Yeah, so we have a lot of project-based learning activities. So every year has quite a significant project. So there's a first-year project which involves designing a car. Again, it's an integration between electronic and mechanical design. There's a big project in 3rd year, which is called the Fireman Project, and that involves developing. So it's been kind of slightly tweaked for this program. For this new program, you have to use an renewable energy source to power a device, to pump water, to put out a fire. And then obviously in 4th year or 5th year, depending on which route you go, there will be a large capstone project. And most of the modules will have some lab or hands-on activities associated with them as well. So yes, there's a big emphasis on theory, but there's also a strong emphasis on the practical applications and the applications of that theory.
Brilliant. Gary is saying, if you choose, I think is this course, and then work out that you would prefer to be in another of the engineering disciplines, can you transfer after year 1 or do you start again?
No, yeah. So basically, year 1 is common for everybody. And as I said, you have different options. You can pick the common engineering route and then make a choice at the end of 1st year, or you can pick a denominated route. And if that still suits you, that's great. You just stay on that denominated pathway. If, however, you choose a denominated route and decide to change your mind after first year, you have an opportunity to change then. But first year is really the cutoff point, because the different programs get a little more specialized in second year, and particularly even more specialized in third and fourth year.
Yeah, that's great. And this course is part of the DCU Futures, and that won the Student Experience Award or the Education Awards recently, which what impact has that had on the course?
So there are a number of elements which are tied in with Futures. So what we've tried to, I suppose, incorporate in this program, there's a number of different things we're doing. There's a 15% online delivery, which allows the students some flexibility. We have meaningful industry engagement. So as part of the design of this program, we were very closely linked with a large industry partner. So they helped us in kind of shaping the program, and they're also providing some, I suppose, practical industry specific challenges to the students as they move through the program. We also are trying to develop a lot of innovative teaching and learning activities throughout the program as well. And there's a strong focus on transversal skills. So even though we obviously have our strong engineering skills, we're trying to embed transversal skills throughout the program also.
Brilliant. And I know then, as part of the DCU Futures, the students can, if anybody's interested, take up a language. So as part of the DCU Language Culture program, and that would include French, German, Spanish, and I think Arabic also. So there's lots of information on our website about that. But we'll finish off, but Lorna, that was absolutely excellent and very, very informative. I think there's no more questions coming in. This has been recorded and will be sent to everybody who attended today, just to remind themselves. So unless somebody has a quick question, because we have to finish up at half, I don't think anything else is coming in.
And just to say, I mean, if anybody would like to contact me by email, if you have any specific questions after kind of, having a think for a couple of hours or a couple of days, by all means, just my email address, you should be able to find it online on DCU. By all means, drop me an email and I'll respond as quickly as I can.
Excellent. Thanks very much, Lorna. We should pass your email along to people who want it as well. But thank you so much, everybody, for attending. And thank you, Lorna, for that excellent presentation. Very informative. I'm sure we'll all, if I was back there again, I would certainly be doing it. It's such a worthwhile course as well. And the work that you do is just tremendous also. So thank you so much. And thank you, everybody, for attending. So we say good evening to everybody. Thank you.
Thank you. Bye-bye.
Bye-bye, everybody.